This paper is taken from 9709 series 63 May June 2023 number 3. So given the size of sample 100, the confidence interval 90%, and then the width of the interval is 0.15792, and then before we answer the questions we need to draw the bell of normal curve. Okay, and then we write the middle number. This is for the mean value for normal, and then proportion for binomial distributions, and then this is the minimum value. This is the maximum value of the range. Let me just write minimum, maximum, and then we have 90% confidence that everything here is close enough to the mean value. So 90% confident that everything is around here is close enough to the mean value. But later when we check the formula reading the z table, we can only read z for this area. So see the difference. Confidence interval area is just like the middle of the curve. But if you compare to our z table, okay, more to the right side. So what we should do is to change the area of this curve by finding the rest of percentage. Since this curve is symmetrical to each other, 90% is taken already. These two are the same, so this should be 5%. And this should be another 5% because we need 10% to have the whole 100%. So we need to divide 10% by 2. So 5% for this area, another 5% for the second area. And then we combine these two areas together to find the z value. We'll be having 95%, and then read the z for 95%, and then the result is 1.645. Then we can put the confidence interval formula, which is p. Since we're not using mean, we're using p because we are asked about the proportion. So plus z, and then times square root p 1 minus p over the size of sample 100, and then another which is for the minimum value p minus z, then p 1 minus p divided by the size of sample. And then if we find the difference between the highest to the lowest, we can eliminate these two p's out, and then z minus minus become double of z. So p 1 minus p over 100, and this is the width, equals to 0.15792. And then to find the p value, we need to divide everything by 2z, and then this is 2z. So we can substitute the z value, which is 1.645. So later we'll be having root p1 minus p over 100 equals to 0.048. Sorry, 0.048, and then we need to square both sides because we are finding p value. We don't want to see the square root. After squaring both sides, we'll be having p 1 minus p over 100. So the square root is gone already, equals to 0.00234, and then p times 1 minus p equals to times both side by 100. So we just move this dot twice, so we'll be having 0.2304. We expand this function, p square minus p minus p square equals 0.2304, and then we move everything, we combine everything together to have quadratic function. We'll be having p square minus p minus 0.2304 equals 0, and we take our calculator to okay, take our calculator. So p equals to 1, and then p equals to minus 1, and then 0.2304 equals to, okay, we got this first solution of p 0.36, then the second solution of p is 0.64. Then, so that's the way to apply confidence interval to and to find the value of the two missing proportions. And then this is not the question. This is not, oh, still not yet. Yeah. We still need to find, this is still the proportion. And then we get to find x students. So we need to do x over 100 equals to 0.36. So the first x is 36. The second x is just 60.2. So for another value of p, we'll be having 64 in total. Okay, that's all. This is the answer for paper 3. Sorry, paper 9709, series 63, number 3.